The thing with these challenges though was that there was like
Levanto, is your audio okay ama unasikia ni kama unakatika? Is it me alone? Tukman,
I think she's okay.
it's okay.
Yeah.
you need to
But
fix your
but
network.
basi ni kama ni yangu.
Yeah, I'm also
Kuna
here to
mtu
record.
kuna
Yeah.
mtu ana torrent hapa ni kama
Me, I think my network is fine. I mean, my quality is fine. Sindio?
Yeah.
I don't know. Okay. I hope everyone has like unzipped the challenge and maybe looked at the into the folders. So I can say maybe we start with baby both. If you have questions, you can ask, or if you're even fine to like share your screen as you do it, and then we can just go through it.
Yeah, actually that would be way
Whichever
better.
way that works.
Yeah.
Yeah. Okay.
Yeah.
I think in order of like easy to hard to relatively hard, the baby buff was the easy one.
So you said you start with check sec.
Mm-hmm. By the way, Mugenjutsu, should we record this?
No, don't record me.
I already started recording when the call started.
Okay.
I guess it's fine.
It's
No
fine. It's
biggie.
yeah. Okay.
Okay. Don't know, it's this weird. Okay, see, no start canary. NX is enabled, no pi. What else? Yeah, guess that's it. So next, checking functions. What was the...
It was read elf actually.
Oh, read out.
Yeah. So like trying to read through the symbol table. Since we see it's not stripped, so it's read elf dash dash sim syms.
Symbols.
S, there's an S there.
Oops.
Yep.
So I see this win, this main, and setup, right?
And I think setup is usually a default function. No, it's not. It's not. Sorry. Yeah, setup is fully. I was thinking about
Init.
I was thinking about something else. Yeah.
So anything static we can get before going to, because already have functions. So I'm just thinking next to go to DB.
Yeah. But you can also if you want to look at hard-coded strings, you can check it via obj dump. So you do obj dump minus sj and then just 1 minute. Yeah, obj dump minus sj dot row data. So like you're trying to view the dot row data section main. Yeah, like that.
Mm. Yeah.
What that will show you is like the, as it says, the content of the raw data. So you can get some clues. Like for example, we can see cat flag.txt, so we know it's trying to read this file. And we can get the address of where that string is, like cat flag.txt if we need it or something. Yeah.
So I'm assuming the address is somewhere around this part. Or
So
there. Also
so you
need
want to
to
get, sorry. So you want to get the
add,
address of what? Of cat flag.txt.
yeah.
Yeah, so in that case it will be 40200C, right? Because where the C starts, like where the string begins, it begins at the last the last 4 byte section of that 40200, right? So it will,
Okay, got it.
no, not that one. It's there at the 666C at the end. Yeah, there. Because 66 is C. Yeah. So that string begins at from there. So that's address 40200C. And yeah.
Wait. So
Mm-hmm.
this is the address, then this is the
Yeah, the content.
so I'll need the dummy flag text here.
Yeah, it seems so, right? Um, we're just extrapolating based on like what we can see now. So we're just being like, okay, we need a dummy flag.txt. Yeah, since it's trying to cut. Yeah.
Yeah. We can now head over to GDB. What else am I missing? I remember.
Hello.
Hello?
Yeah, you're saying?
So I'm assuming we are done with static analysis.
Yeah,
We can
there's
now head over to GDB.
yeah the you can also like decide to disassemble the functions, right, to kind of understand like what it does, but you don't have to. uh, you can choose to do it now, or you can choose to disassemble as you're in GDB. um, yeah,
Okay.
for
So
me I
still,
usually like just checking through, just quickly glancing over the functions. Yeah.
also we can still use object dump.
Yeah, so it will be obj dump minus d, and then the name of the file. We can set the flavor, right? Minus m Intel, capital M. But I'm not usually sure about like what's the default flavor. Uh, I've never tried to see like if doing it without will make a difference.
Let me see. Does it say?
I think that's like independent of obj dump. Like, no, wait. I'm not sure. Anyway, that it's not that important, I guess. I'm not sure. Let me check offline.
I see there's a couple here. Intel, AT&T.
Oh, okay. Well, I guess as long as we can be able to switch between them, it's fine.
I don't see default anymore.
Okay.
Default. That's fine. The default would be selected register. I can't find it.
Okay.
So we can continue.
Yeah.
I see we have main here.
Mm-hmm.
There's a call to setup,
Mm-hmm.
a call to put, call to print, call to get. What else can I see?
Okay. So
The
yeah.
set
So
the
here.
size of the stack, right?
Yeah. Sorry. Sorry, I didn't hear you.
Like, does this mean this is the size of the stack?
So that's like, so the first 1, 2, 3, 4 lines. It's usually mostly 1, 2, 3 lines. I usually like the setting up entry function. So it like initializes the stack of the program, as you said. So sub RSP minus OX40. This, by the way, is usually variable. Like it varies. So most of the time, it's like okay, set up this size to like be able to accommodate any variables that we might be putting in, any parameters that might be putting in. But the first 3 lines are usually entry functions. You see this in the beginning of any function that's being loaded. So yeah, so we're like, okay, push the value of RBP, set the pointer of RSP to be the same as RBP, okay, and then create the initial stack, as you said. Yeah. Yeah, and it's usually the entry has an exit also. So the leave and the ret are the exits. Yeah. So the leave actually, yeah. So leave is usually like it abstracts the opposite of what we did. So like pretty much destroying the pointers, the RBP, RSP to like think of it as like constructor and destructor actually, like classes. Yeah.
Okay. Mm.
So, oh yeah, so I was saying the interesting stuff here is like, so you saw there's a call to get, right? So that's like we're we're feeding an input. So here I would look at the parameters that we're putting in and like where stuff is being put in the stack. So I think get has one param. Let me see. Yeah, I think get has one param actually, which is usually the place that you're putting in. Yeah, the pointer to where you're putting your input. So in this case, it's RBP minus OX40.
This one.
And yeah, and then we know that get actually is vulnerable, right? Because we don't specify the size of the input. you can put an arbitrary number of inputs. So when you see gets already, there's like a clue that there might be a buffer overflow here. Yeah, so that might be one clue. Yeah. And then also like where we're putting in the input. So we're putting the input pretty much at the top of the stack, right? So there is a potential that we might be able to overflow all the way down to the return function, the return address of this input. I mean of this function. Yeah, as you will see. So I can make a wild guess here that all right, my buffer overflow offset where it will offset will be at the point at the offset OX4, not 40. OX40 is what? Let me is 64. Yeah, I can make a guess that it will be at the offset maybe plus 8, 72. But we'll explain that later as we go on. So you can continue.
Is it necessary to check out setup really?
I guess just to see, but if there's nothing important that can help you in your exploit, then not really. Yeah.
Don't see much.
Okay. So the win function, I guess, is the one that's worth checking.
What is a call to system?
Mm-hmm. And yeah, so again, sorry, continue.
So I'm assuming it takes parameters and
Mm-hmm.
the parameter is in RDI.
Yeah. Uh-huh.
So our string must be in RDI.
Yeah.
Then
So, uh-huh.
the cat flag txt. That's what I'm assuming.
Yeah, sure. But you can also be able to check like what string this is, right? Because you can already see there's an address there. Like it loads the load effective address, right? It loads the content that is in RIP plus whatever, which we can see is 402008, right? It loads that content into array X and then moves array X, the content of array X into what is in array X into RDI, right? Uh, so we can use X slash, maybe we say,
This
maybe 5S. Yeah, yeah. So X is examine command. So wait, no, sorry. I was thinking we were in GDB already. Right.
I
But
can even go
anyway,
to GDB.
yeah, sure. But anyway, another way to check this, if you see a value like this that is being referenced from RIP plus whatever, good chance it's hard coded. So uh, pretty much hard coded anyway. So you can just do what we did, right? To check the .ro data, because hard coded strings are usually put in the .ro data. Yeah. So what we did initially, the obj dump minus whatever dash sj.ro data main, right? And we were able to see that okay, this is where the stuff is at. Yeah, that one. Yeah, yeah.
Wait,
So
someone
you can count. Hmm? Yeah. So it's 408, which is four. That's the one, two, three, fourth column, right? Beginning 63, 61. Yeah, yeah, there.
that's it.
Yeah, exactly. So that's like the address of the string that it was. So Yeah. So now I guess you can be able to have like high level, like what the win function pretty much does, right? It's
Yeah.
like, okay, cuts the flag pretty much. Yeah.
So
Okay.
that's to
Mhm.
all these strings.
Yeah, if you see RIP plus OX, because it provides you what's this called? It provides you an offset, like a static offset. You can see it, RIP plus OX2, whatever, whatever. So meaning that this is some hard coded either value or hard coded uh, what's the word, map. I don't know if that's correct to say it like that, because some of them you can see they're like they point to like some function, right? Like the one you saw. Um, yeah. I think we can be able to inspect. Yeah, so you couldn't see it here, right? Because as you can see, that data row A data is this is the whatever the size of data row A data. So what I'm trying to say is that not necessarily that the hard coded stuff are strings, right? Some might be pointing to a table that that shows you like, okay, this is where my system at PLT function is at. So yeah.
Okay.
So
Just give me
yeah.
5 minutes. I hear
Okay.
some of it.
Okay, cool. All right. Okay, so we take a break or someone else share the screen. Astra, where you at? No, Astra.
Yeah, I'm here, but I do not have the binary. So
See, you don't have the binary. Si iko hapo kwa
I'm saying, well, I'm
they're
trying
in
to
the
find the binary.
they're in the reverse engineering channel.
Okay, let me.
By the way, the guys who've joined, we're doing the binaries that are in the reverse engineering channel. Pond.zip. Musioka, Saint Click. Did you guys try them out? No.
Musyoka says no in the chat.
Ah, okay. Saint Click. Okay, sure. If you
That's
didn't do
correct.
it, it's fine. If you didn't do it, we're just having like a chill session, so you can just follow along. Just it's best to just do it as we're doing it. Just unzip the stuff, go into the first one that we're doing, baby buff, and then yeah, do it with us. If you have questions, just ask. Yeah. Okay, took.
Yeah, so we can head over to GDP. Oh,
Sure.
you're saying something. I
Uh, nope. Sijaongezea after
sawa.
you left. Yeah.
GDP. So I see that the server. So you can just run, right?
Yeah, sure. You didn't do the gmod plus x. Okay.
So that was okay. Okay.
So there's something we can use to fail to find obj. I'm not sure what that is.
Let me
Anyway,
just
maybe we just continue until we find an issue.
I do.
You need to control D to exit. Yeah. Okay. So there's the thing we could use to be able to find the offset, right? For the overflow, as we said, which is pattern. So we can do a pattern create and then give it an arbitrary number. So in this case, because we saw the size of our stack was what, x40. So for me, I can say, okay, let's try maybe plus 16. So we say x40 is 64. So you can just estimate, okay, 80. So pattern creates pattern of 80, and then you feed that in to be able to check where there might be a possible buffer overflow. Yeah.
For some reason, pattern create doesn't.
No. There's no underscore.
Just one word.
No. 2 words.
Pattern create.
Yeah. Yep.
Ah,
Yeah.
that's how I messed up. So shoot. It doesn't have. Okay.
Right.
Um,
Okay, sweet. So we found a 6F.
yeah. And
Nice. So, so what does this mean? Like finding a 6F. What does that mean? From the logs that you can see there.
mhm.
Yeah, because we can see, okay, it stopped at our red function, right? And we get a cannot disassemble from PC. And we see our RSP up there. It's like JAAA. So that gives us a clue that, okay, it was trying to return, but then couldn't disassemble the function. I mean, the address that is at RIP, right? So that's pretty much that we overwrote the return address. Yeah. So now, so now I think we can be able to find the offset, right? We're like, okay, at what offset of our input did we overwrite the return function? So now you can do, oh yeah, so now is where you can do the examine the x. So you can do x slash xg to,
G.
yeah, so without the space. Yeah, and then slash, not slash, I mean $ RSP. So that gives you the value of the what was in RSP, pretty much. Yeah. So now you can take that, the OX, that value, and then find the offset. So you do pattern offset that value. Get at what point did we overwrite? So doing xg pretty much gives us like the 64-bit value in hexadecimal. So it gives us the 8 bytes pretty much in hex. So that's why we did xg. Yeah.
So for the offset, I pass the hex value,
Yeah.
not
Yeah. Yeah. That
the
hex
whole thing.
value. Yeah, just the whole thing. I think last
Oh,
time Muginjutsu showed us how to do it with PwnGDB. I
cyclic.
guess you can do,
Was cyclic.
yeah, cycling. I think it's it's native in GDB, right?
I think cyclic was for one.
Cyclic is only for
GDB.
pawn TGB. So
Ah, okay.
so you do cyclic, give it a number, it creates the pattern, and then if you wanna check the offset, cyclic tac L, and then the first 4 bytes of RSP.
Ah, okay. So by the way, Muginjutsu, you see now, like we're pretty much doing the same thing as cyclic, right? Using pattern offset. And then here we can just provide the whole thing, right? But in
Yeah,
cyclic, it gives like a limit or, yeah,
yeah, of only 4 bytes. Yeah.
yeah, all right. Uh, okay, Flame. So we saw that the offset is at uh, 72, right?
Oh yeah, for little n1.
Yeah, 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 72. So that kind of makes sense, right? Maybe to like just explain why it's 72. So as we said, so in our entry function, we did push RBP, move RBP, RSP, no, RSP, RBP, whichever. And then we did sub RSP, right? We did sub RSP or X40. So that pretty much we were initializing our stack to be a size of OX40, which in decimal is what is 64, right?
Any other way
Now,
to conversion
yeah,
in GDB? How can I convert this to
I honestly I don't know. Um,
John Collins? Any idea?
What was the question again?
Do you know I can maybe convert X to decimal via GDB, or how do
X
you usually do
to
it?
decimal. Um, okay, the best way to do it, I guess, is using, just like the way you used x slash xg on, the RSP. I guess you could do something like x slash xb for, no, what is it? I think xd for decimal. I don't know if that's what you wanna
mm,
try.
but that's oh yeah, XD. But that wouldn't. So I think he was asking like, okay, we have a value, a hex value, and we just want to uh, convert it to decimal in
Okay,
GDB.
the best way is just maybe open a new tab and then Python 3 and then just slap that value in. I guess that's the best way of doing it.
Or
Yeah,
maybe Python
Okay.
3 is
honestly.
the short.
Nice. Yeah, and then I guess you need to print, yeah, and then put the value there.
Oh,
Actually, I see one. They say uh, you do E. I know, but this gives you in hex and
Don't pass it in as
wait.
a string though.
oh,
Just pass
string.
0x40 without, cause it's not a string. You wanna print it's actual. You're passing it as an integer, so don't put it in quotes. Just 0x40 without the quotes.
Actually, there's an easier way
Oh really?
on GDB. Yeah,
Okay, which one?
you just do P slash
D.
to do P slash D. Yeah, P slash D, and then your variable. OX40. Yeah.
Nice.
Wait, so instead of x slash, oh yeah, makes sense.
Yeah, makes sense, right?
Yeah,
Because it's like print,
yeah.
print in decimal. Yeah. What was I
Making
saying?
note.
Oh yeah. So yeah. So that is pretty much 64, right? That's the size of our stack. But then that means where's our return value? Our return value is right before that. Um, yeah. Does that make sense?
You see, you're explaining size of the stack is 64.
Yeah.
So our return
And then
value is right before
is before we set up. So it's like you have to
all this.
imagine like it's like ad infinitum of there's a larger function that is loading this function. There's a largest whatever that is loading our current program, right? Our current oh no, actually no, let me just be a bit technical. So our main function is usually loaded from some init functions. There is a dots I mean dash start dash hyphen no dash start. There's a dash start, there is dash init, there are a bunch of init functions before we get to main.
Mhm.
So I think is dash start. Let me just be sure. I have a couple of notes for this. Yeah. Anyway, while I look for it, so when you're loading a function before you start loading the stack, before the stack is loaded and all that, the return address has to be put in. That's the same for printf. There, when you do call printf, before we load that function, the return address is put into the stack, right? So in that case, for example, call printf, the return address will be the next one, will be 41212, because when we after we do the printf function, we have to return at some point. So we have to return back to the parent stack, right? So the same case with this main function. So the return pointer, I think it's I need to find this. I think it's dash. There's a dash fini or something. But we have to return back to where we called the main from, right? So which means that the return address for our main function is before the stack, before the stack. So in this case, it will be 64 plus 8, which is 72. 72 plus.
I
I
think
think I'm getting something wrong though.
no, hapo
Yes,
nimeshika.
it makes sense. Okay.
Yeah, makes sense.
Pardon me. I think maybe I have
Mbona utas-
okay. Maybe I have confused the numbers or the names of the functions, but that's pretty much it. So I just need to find the notes and just send them to you guys. Yeah.
Okay,
So in this
if I
particular
could just
challenge, sorry.
maybe if I could just summarize what you said.
Mhm.
There's a function somewhere which calls main. So maybe it
Mhm.
has a call to main, right?
Yeah, that's I think is dash start.
Or dash start, let's say, has
Yeah.
a call to main.
Mhm.
Then within a main, it has
Mhm.
its stack
Mhm.
uh,
Mhm.
with a size of 0x40, which is 64.
Yeah.
So when main finishes,
Uh-huh.
it has to return somewhere. So
Yeah.
that means,
Actually,
yeah,
sorry. There's something I forgot. So the leave function, as we said, it pretty
yeah,
much does the opposite of what we started. So
yeah,
we
exactly.
removed RBP, right? I mean, we pushed RBP into the stack. So in the end, before we return, we need to remove RBP. So my calculation was wrong because of that, actually. So it's 64 plus 8, which is 72. So 72 is where things are okay, right? But then past that, we start overwriting into the address. So, which was pretty much like, okay, the stack 64 plus RBP to be removed, and then after that is now the return address. Yeah. Uh, yeah. So you were continuing. Um,
So whatever we'll be returning will be the size of main stack plus RBP. Then from then on, that's where we'll
yeah.
now start overwriting.
Yes. 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 So in this challenge, we could have easily inferred the offset uh, without having to do the pattern, though that is still fine. Yeah.
Okay.
All right. So what do we do next?
So I think next we should get address of win,
Mm-hmm.
then create our payload, which would be 72 bytes, then add address of win.
Okay. Cool.
Is that correct? From,
Let's see. I mean, if it's the good thing with this stuff is like there's you just go with like the facts, right? If that makes sense, that okay, we've established this is the return address and this is what happens, and then we're like, okay, let's overwrite it with a function address to jump somewhere, and all that makes sense, then that should work. So, so that's how I was saying. Let's see, it should work pretty
okay,
much.
last time out, I
Yeah.
saw you tested it out with passing uh, a rope, a knob sled, or what is it? A couple of
Yeah,
knobs.
no. But that was I
Yeah,
was trying to execute some instructions, right? But this we're trying to jump to some address, right?
some
So
address.
we might as well test it with the address itself. Let's see. All
Okay,
right.
maybe I can see.
Oh, actually, another thing I think you saw it was that the fact that we were able to just take this address here is because we saw that there was what was it PIE not enabled. PIE was disabled. So that means pretty much that the function is being loaded as a static address.
Okay. So we send it to a file.
Uh,
What what's the best way? Let's just
Um,
print it out.
you can, yeah, the best way is maybe doing it in one line. At least if you're not writing a script for it, you could just put the whole payload in one line. So maybe print a times 72, and then um is it a plus? Then plus the address of win.
To address of win. So in our case,
I think the plus comes after you close the bracket for print, or I'm not
uh,
sure. Okay, yeah, let's just do it this way. I barely do it on one line, but it's fine. Just you can do it that way first, and then we see. So now you have to change the endianness. So the way you pass the address.
that's C7,
Yeah.
11, 40. So let me see. 1, 2, 2, 3. How many do I need? Do I need 8?
Yeah, you need 8. So it has to be 8 bytes, so you just pad it with null bytes until it becomes 8 bytes long.
So I add 4 more.
Yeah, exactly. Oh, you could just put it, yeah, as one. Yeah.
Wait, it won't work without the zeros?
I'm not sure. Just curious.
I doubt
Okay.
it will. You know, it's a 64-bit binary, so it must handle the addresses um
Okay.
with 8 bytes.
We can always try both.
Yeah, you can try both.
So maybe we'll start with 8, 1, 2, 3, 4, 5, 6, 7, 8. So should I print it to terminal or send to file?
So now you no, you pipe it to the binary. So like pipe
Then
then
it will be easier to do it. Okay, so how do I pass this output to GDB? Let's say if I
to
was not directly running to a file.
aha. How'd you do that though? Well, I guess what you could run and then you could have the R and then um that whole Python 3 command, I guess. I don't know. But the best way it's doing it outside of GDB. And I noticed like sometimes you can run something in GDB, then when you run it on terminal it doesn't work. So yeah.
Let's try it outside. Send it through. Did I mess up?
Okay. Um
It passed this. What is this? It passed the string or what?
I
huh.
know
I'm not
Python 3 usually has issues.
Okay, this is interesting.
Can you just? Oh yeah, maybe just try like
Maybe do
just
Python. Yeah, Python 3 has issues. I see we have the flag.
ah okay,
Yeah, so guys, watch out.
interesting. Like
I think the
why didn't?
encoding.
Hmm.
Let me just see.
Yeah, for
I
Python
think it
3,
encodes.
according to live overflow, you're supposed to use sys.standardout.buffer.write, I think, when you're passing that address. That's why I hardly use like that one line way of doing it. Can really mess you up. So yeah,
Yeah, but that's pretty cool. For me, I usually just since recently I just write a script, use pawn tools,
sweet.
and just
Yeah,
send.
nice.
Yeah. Because it's easy to just have a template, right? That you can just be modifying from.
Exactly.
Like Mukinjutsu created a custom package for himself to do this. So yeah.
Okay, we can test the one with four bytes.
Yeah, sure.
Actually, without even the last zero. Yeah, just up to OX40, just to see. No. Okay.
Like I said, yeah,
It
it really
doesn't
needs.
automatically pad.
Yeah, it
You
really
have to
needs
like
that.
add it. Yeah. Okay.
Also,
Yeah,
also 4 doesn't work. Just has to be 8.
Yeah, yeah.
Yeah,
If you
yeah.
put it with just one, it's kind of like if you look at it, it's like you're telling Pawn Tools, pack this, for 32-bit binary, so it still won't work really.
Mm.
Yeah.
Who shows in controls?
I would really want to try out the sys.standardout.buffer.write thing, but it's a lot of hassle.
Oh, yeah.
What's
Yeah.
what's this?
I can still try it out. Let me try it out.
Sure.
Just
Okay, I hope you all can see.
Yep, yep.
Sweet. So, um,
Discord has like a lot of noise.
um,
Yeah, when somebody is joining. Sorry, sorry. Continue.
so, this is how you're supposed to do it. I tried using a buff variable, with the A's and whatever. Then, I got stuck. It kept telling me this. So, um, so you import sys, yeah, and then now the way you're supposed to pass it to the the binary, unlike in Python 2, you have to add this part here. So the sys standard out buffer dot write. So I just made a guess that you could even pass the A's here, but this address really needs this here. So now if you try pass it to the binary, you get the flag. Yeah, that's the difference between Python 3 and Python 2, and that is why people like doing it in Python 2 and not Python 3, because Python 3 it's too demanding. So yeah, that's how you're supposed. I'll get the video of Live Overflow talking about this, but yeah, that's how you're supposed to do it.
Ah, all right.
Yeah.
Pretty cool. Sweet.
Yep. Let's go to Securinets. What was this baby rope? I didn't solve it. Oh, okay, cool.
Really?
That's cool. Um,
Okay.
let me do the usual. So I usually use R2 Radare to analyze, do static analysis.
Okay.
Um, so there's main, there's the setup you guys were talking about. There's puts, there's gets. Let's look at main. Okay, the usual setting up of the stack, calling setup. Um, I guess it's asking for inputs. So whatever you say. So puts is writing this on the screen, and then I have no idea what this is doing. Then it's doing a gets on
Oh,
your inputs.
hmm.
Yeah. Um. Okay, that's cool.
So the three lines before get,
Uh-huh.
it's pretty much like setting up the parameter for which one is this? For the pointer to where you put the input.
Oh, okay,
So when
okay.
you see, yeah, yeah, pretty much, you're setting up the buffer for where to put the input. Yeah.
Interesting. All right. Again, bad habit. Should have started with checksec, but it's okay. Let's see. No canary, no
Very bad habit.
PIE. NX is enabled, so that's bad. No shellcode, but um,
Mhm.
yeah. What was no PIE again? What's Pi for? Could you?
Pi is like
Uh-huh.
position independent executable.
Okay.
So that means that every time if if a binary has pi enabled, that
Uh-huh.
means that every time we load the program, it will be loaded at a different point on the virtual memory address. So it won't be at the same place. It's similar to ASLR, by the way.
Oh, okay.
Um,
Uh-huh.
yeah. So there's no pi, as you can see, the base address is always static. So as you can see, it says that the base address is OX400 or whatever.
All right.
Yeah.
Okay. Okay, cool. All right. What was I supposed to do next? So just, running it and seeing what it's all about. Just passing in random A's. Does nothing. So here is where I would use my custom library to see if I can oh, import star fuzz the okay. So the offset is a 72. So what happens after we pass in a new OpenGDB and cyclic 73? See what happens after that. Wait, is it? Yeah, 73 is where it will crash, right? Because 72 won't do anything. I guess
72.
that's the logic.
Like the offset is at 72, right? Like after 72, you start overwriting.
To hit
Yeah,
the return.
yeah,
Yeah, it should be.
yeah.
Wait, I've seen you, Moduns, I've seen you do like Python 3 something import from flag, fuzz
That's a custom library to fuzz to
to get
when I'm
the offset.
yeah.
Oh,
Okay, guys,
and
give me
w-
1 minute.
y-
I go. I'll be AFK for a bit. It's
Okay,
fine.
okay.
sure.
You can continue.
Um, and let me could you show the library how it looks like, or the function itself?
Sure, yeah. Ooh, my I think my VM is crying. Okay, user lib
Which VM is this?
the VM.
Uh,
So wait, you asking about the distro?
yeah, the distro.
It's Kali Linux genome, but it's
Ah,
way customized. Yeah, it's super customized.
oh, you can also customize the icon for start. Okay, that's
Yeah,
interesting.
yeah,
Mhm.
yeah. Okay, so
Oh,
where is it? There are so many things
fuzz.
here to solve very different
Give
challenges.
arrays for what?
So this is a challenge where sometimes you get a GIF image and then there are just like many strings being thrown everywhere, and you have to convert that GIF to a PDF and view the images. Um,
Oh,
and then normally it's usually like base 64, so you need to find the correct order of those strings in order to decode to a proper string. So this one
okay.
just does that. Yeah. Enough of the fuzz here. So it's just doing a while loop and it's trying to. So I tried using so there's a different way of finding the offset. You could just overflow the binary and then read in the core file, and that's
Yeah.
where yeah. But mm, my kernel doesn't generate core files. I don't know what's up, but
Oh, you can enable it on the terminal itself.
yeah, I tried, but I don't
It
know.
doesn't?
I think it generates one, but it doesn't generate one in the current directory, which is so weird. I don't know.
Oh,
Yeah.
okay.
Anywho, so I found a workaround for that. It's just doing a while loop and it's trying to echo A's to the file, and because it's using subprocess library for this, the check output. Once
Mm-hmm.
the program crashes, it's going to complain that it has. So it's going to call this error, and so once it does that, I know that it has overflowed the binary, and then that's where. So at that point, at that value for C is where we'll have our offset, but then it's gonna also check the architecture. If it's a 32 bit,
How
then you
does it check the architecture? Oh,
yeah,
you did the file
so it does
command.
a file, yeah.
Okay.
um
Oh, okay.
yeah,
But this is nice. This is interesting and simple
yeah,
on different environments.
Yeah, yeah. So if it's a 32-bit, the offset will be 4 bytes added to that C value, because 32 bits behave a bit differently when it comes to um overwriting the return address, upon the when the program overflows. But if it's a
Oh,
64, then yeah, that C value is the offset, and then um it just returns that value. So the whole point of this is, if I'm participating competitively and I'm writing a script, I don't need to open GDB to find the offset. I can just
yeah.
import
Do a fuzz.dd.
yeah. So here, okay, this one. So another funny thing is this script will be generated automatically when I call this function here. So now within this
Oh,
script, now it will replace this with the name of the binary, and then I can just run that script automatically, and it will solve the challenge depending on what was expected. But
wait, how is it replaced the challenge? When you've passed
it's
arguments to pass. Oh, okay.
yeah. Uh, one way I could show you, I could demonstrate it a bit, is we go to the simple overflow, the overflow what challenge at KCA. So this one
Mm-hmm.
was just you run the, was it chal? You just pass in A's and then it overflows and gets the flag. But a cleaner way of doing it now is let me close this and let me see the files I have here. So let me remove this. So I can just I do Python 3, then from flag import star, and then solve the simple both child, and then pass in the name of the file, the host, so that's the IP I want to reach out to, uh, yeah, the port as well, and the receive until, so maybe it's a colon space, and this will create the solve script automatically. Let me just confirm the receive until is that. So you can imagine I already have the script, so if I just run this, it gets the
Yeah.
flag. That's it. I'm done. Um, same thing for
Okay.
the other pawn child. It was called what, red to win. Yeah.
Mhm.
So this one was you you overwrite the return address and then jump to win, right? Um,
Yeah.
it can do the same thing. So if I just do Python 3, sorry, from flag import star, and then solve, in this case it's simple both, and then win, because we are jumping to an address. So I just pass in the file, the address that we want to reach out to remotely, the port, um, receive until, and the um, what the
And win.
function I want to jump to. So it will create a script there. um so I always just comment out the ret gadgets. sometimes
Mm-hmm.
sometimes you might need it, because sometimes when you um the moment where you overwrite, like when you're trying to jump to an address, sometimes the stack gets disaligned. So sometimes I think you've seen the move ups, uh should I call it an error or something, in GDB
Yeah, move up
sometimes.
the issue.
Yeah,
It's
so
an issue.
you're very sure, like I've done everything correct, but then you need to align the stack. So sometimes if that's the case, I'll just uncomment this out and then just run it. So what was the receive until for this? Okay, yeah, so that should work. So if I just run this, um it gets the the flag. In this case it spawned this shit. But yeah, that's
Yeah, you can. Could you mind sharing the that's it's a neat trick Someone
Sure.
can edit it. Yeah, someone can edit it to their liking instead of creating the whole thing. I actually because the time I was trying to write a whole automation script for um finding offsets,
Uh-huh.
but I used the core files. So,
Oh,
but I was
okay.
wondering what if in the scenario you don't have pawn tools installed? You
Oh,
just
yeah,
want yeah
exactly, yeah. So what should I share here? Should I share, let me just
everything.
do,
Just share the whole file.
oh, the whole file, yeah, sure.
File will be pretty amazing.
Huh. How do I do this? So, one sec. Go to files. Oop, so let's use a lib Python. Yeah, there we go. And here we go. Cool. So now I can share it. Should I zip it? I don't think it needs zipping.
I don't think you need to zip it. You can share it on the chat or
Let me just share here.
yeah, okay. Bye.
Sweet. Yeah, so that's it.
Yeah, thanks man, thanks man. Now
Sure, sure.
you can continue.
Let's go back to Baby Buff because it seems I didn't solve this one, which is very interesting. Um, let's see. Okay, so at what point did you were you okay? So if
I
it's
am back.
oh, you're back, awesome. Cause frankly, I have no idea how to do this. Cause whenever I think ROP, I think like the shell hard. So I think that's why. So after we did shell hard, I realized it was easy if you just knew what you're supposed to do. But for this one, it's ROP, yes, but um, and ROP is
Yeah.
basically writing your own program inside another program, if I'm not wrong.
Yeah, so it's
Think
like,
for that.
yeah, you're leveraging the return, um,
Ellipse.
the red pretty much
Ah, okay.
to move around. Yeah, and like execute stuff or manipulate memory, add parameters, things like that.
Because I didn't solve this challenge, but I guess um because I don't see a cut flag somewhere, I'm guessing you're supposed to get a shell.
Think so.
After yeah. So the I guess the purpose of the rope is spawn a shell because they didn't mention anything about flag.txt somewhere, at least as far as I can tell, and even after doing static analysis. So yeah, let me just assume that I can use libc to spawn a shell.
Mhm.
Let's do that because okay, this is weird. Let me just close this. Okay. Securinets Espirit baby rope. That's okay. Oops. I already made okay. And this was like this wasn't recently, this was a while back, so let me clean it up a bit. Target elf, what's the file called again? Main.
Baby Rob. Baby underscore Rob. Oh, it's
Oh
main.
no, yeah, it's main. This is the folder and this is the binary
Oh, okay.
here. Oh, there's a main.c. That's interesting. Let me look at
Yeah.
that for a bit. So it
Where
does
I went.
You went.
Like for for a few minutes, I was like just alone. I couldn't hear anyone or see
Oh
anyone.
damn.
Oh, yes, yeah. Main,
Okay.
and then it's calling setup to set up the buffer, and then sets up a buffer, then
Yeah,
puts, then gets buffer. Yeah, this is getting shell because you have nothing.
exactly.
Yeah.
Um,
All right. So what's our entry point?
Libc,
eh,
lib, yeah.
yeah.
We have libc, so we have to utilize libc to find rope gadgets that will enable us to get shell, if I'm not wrong.
Actually, for this one, it wasn't provided. I think when I was doing the chal, I was like, let me try get a libc online. So that one isn't.
Oh,
Yeah, but I guess you
oh,
can use.
But
that
does
okay.
that?
Yeah, I
Ah,
don't think that one
okay.
was there.
Okay, I'm
But I
kind of
think,
getting excited. Okay, we have a lib C, right? I mean, internally.
Yeah,
Is
yeah,
it
exactly.
yeah, or
lib?
even the address that libc is introduced.
So, okay, for me, I think there are two ways of approaching this.
Uh-huh,
The
Uh huh.
first one is like we saw that there was a no executable bit, the
uh-huh,
stack.
Yeah.
yeah.
So we can call them protect and set the stack to be executable,
Oh, you
right?
passed 7. Yeah. Uh huh.
If we Yeah, we pass 7, we find the address of the stack,
Mhm,
we figure out the size of the stack,
mhm.
and then we pretty much make it executable, and then after that we can just
Put in
be
the
able
shell
to
code.
execute the payload that we have. That
Mhm,
or the other way is okay, we find a writable place uh, in the program, maybe .data, and then push our payload there and then jump there, right?
okay.
Uh,
Um. Yeah.
does do does that make sense, guys? Like, um, I figured we just jumped into talking about the stuff that we can do other than explaining exactly how we might do it.
I do
But
it.
It sounds good. Only that maybe I need help with that cause yeah, I need help with
okay.
that one. So let me.
Actually,
Uh
Inside,
sorry.
inside, inside,
I
inside drop. You have to put target, not tie
Oh
your
yeah,
get.
it it replaced all the R's with IO. Like
Oh,
yeah, that's dumb. I just need to replace all of them back. Okay, yes, that's it. Cool. Now, let's see if we can. So let me just comment this out. Let's see if we can actually, if there's, if we can call system. I don't know. Is that a, is does the logic fit in this challenge, Levanto? Can we use libc to get a shell?
uh I mean, we can be able to call system, right?
Yeah.
We need to pass the string to system. Yeah, sure. I mean, that plan makes sense.
Okay.
Now the thing is like how to do it, right?
Yeah.
So like first we need to be like, where's the address of libc? Is
yeah.
it loaded into memory?
Oh, on the
Um,
uh-huh.
On the binary, you have to find the address of libc.
and
Ooh.
then oh, okay. For me, I have a question though. Maybe I
Mm-hmm.
ask the question first. It's a
Sure.
bit
Ask.
so the guys who did retired or like who attended yesterday's meeting for retired, right?
Yeah.
So what the guy did, he just downloaded the libc, right? And then got all the addresses from there, right? He
Yeah.
just got the addresses statically.
Yeah. Mm-hmm.
Yeah. True. Uh-huh.
So will this so for me I was a bit confused because in my case Uh, when I was trying to do it, I couldn't be able to like trying to do that statically didn't the addresses were not correct. They were
Matching.
failing.
Is
So
ASLR enabled in this binary or pi?
No, pi.
yeah, actually, okay. Very stupid. Sorry. You're right. So it didn't work on my machine because ASLR is usually enabled by default. Yeah, because
Yeah,
ASLR is kernel based. It's not
yeah,
program based, right?
yeah. Yeah.
So you either have to turn ASLR off or you have to leak the address, get
Yeah.
the address of
Linked.
system.
Yeah.
That makes sense, right, guys?
Yeah.
Yeah.
So okay, so just another question, John Collins. So the retired binary. I mean, that machine didn't have SLR, right? We can say that.
Um. Yes. Yeah. He did not actually.
Okay. Because if you, I guess if you tried to do it on your machine, it didn't work. Because for me, it didn't work. I tried to do it locally. Um, yeah, instead of like okay, download. I mean, get the payload, put it in a file, and then send it to that. Then send the file to the license, whatever activator. Okay.
Wait. You said the guy downloaded a libc and then got addresses from there.
Okay,
That's what he did.
yeah, you remember?
I stepped out a bit when he was doing the M protect
Yeah,
thing.
that's like he got the libc from the machine.
Oh, from the machine. Okay, I thought
He
he just got one online.
yeah.
Yeah.
No, he got the libc from the machine, and then he just got the base and the stuff like that. But actually, another thing I remember.
Uh
Yeah.
huh.
No. Actually, sorry if I'm confusing you guys.
That's okay.
Actually, he got the base addresses from the slash maps, right?
Yeah.
Got them from the
Maps.
addresses
Maps slash proc. Is it no proc slash maps?
proc slash maps, right?
Hmm.
So pretty
Yeah.
much the program has already been loaded, and we're just seeing where the library, for example, where the stack is at, right?
Uh huh.
Yeah.
Yeah. So it wasn't static. It wasn't static. All right, yeah. So we need to do the same here. We need to get the base addresses of the libc and of the stack, right? In our
Yeah.
case.
Yeah.
Oh, so
Um,
you you can't use the libc
You
on,
can't call without finding the address of libc. You can't call it without finding the address of libc.
and also you can't
So I
like.
think what you'll do is
Uh huh.
first you can like execute and then pause the execution and then check the PID proc slash the PID of the process, and then the maps we see if can it wait, but is libc usually shown at proc
Wait,
maps?
what?
yeah.
Okay.
Okay. Sorry.
Oh,
So,
okay. So it's, and wait, we have put. So another way would be, how do we do it? If you have, oh yeah, wait, I think I'm confused. So you add puts to what? The libc base address?
um,
How do you...
okay, so
Okay, just step me through
wait,
this. I think
maybe
I think I'm a
yeah,
noob.
yeah.
Uh-huh.
Okay, so let's step through.
Yeah,
So
okay.
we have our program, right?
Yeah.
Our binary,
Uh-huh.
and we figure out that we to be able to like get a shell or execute some code, right?
Yeah.
So we need to figure out a way on how to do this. So the first thing is like, okay, we see that we can't execute a payload because the point where we can put the input is not executable, right?
Uh-huh.
The stack is not executable. That's
Okay.
one.
Yeah.
Um, Another thing is like, all right, how can we make the stack executable? Can we do it? So we're like, all right, there's a function. Uh, a system, whatever libc function called mprotect, right? That we can pass parameters to,
Uh-huh.
and it will make the stack executable. So how do we find like where is mprotect, right? So we're like, okay, so this is a binary. When you do file, maybe just do file, file name of the binary, file main. When you do file,
Mm.
okay, no, this kind of doesn't show. Anyway, I wanted to show you like, oh yeah, you can see that the file is dynamically linked, and that is the linker down there. Dynamically linked files means that, okay, there's some libraries that are not found inside that are not compiled with the file, like to get the executable,
Uh-huh.
but we load them when we want to run the program, right?
Yeah.
So, like, okay, now you disassemble and you find there's a puts, there's a system, there's whatever, and you're like, all right, there's definitely libc being used here, right? But we need to find the base address of our libc.
Yes.
So what you do, you're like, all right, I need to first load the program then. Okay, so I load my program,
Uh-huh.
maybe via GDB. Okay, do GDB main, yeah, via
Okay.
GDB. All
Yeah.
right, cool. And then I say, let me see where the stack and or like where the program was loaded into memory, right? So I'd be like, do a info proc mappings. Um, yeah, so do info proc mappings.
Rock. Um.
No, just proc without the slash.
Okay. Sorry. One sec. It's
It's fine.
logging a little bit. Okay. Info proc, and then mappings. It's one word or
Space mapping.
okay,
No,
Slash.
space.
like that.
Yeah. Mappings is S. Sorry, S.
Um.
Huh?
No, you didn't run it. Sorry.
Oh,
You
so you
got
run it
to.
first. You have
Okay,
to run it first. Okay.
main. Uh, no,
Break
that
at
will
main.
fail.
You have to break at main or something.
Okay. Okay. Cool.
Uh,
Um. All right. How do we? Let me just. This Securinets Espirit. Um. We break. Oh, this doesn't show me the. Well, that's sad though. Can you just
huh?
disassemble from here?
Yeah, you. Yeah. I think you can just
A
call the
main.
function. Like you
You
can
can just say
say.
b main. Breakpoint main.
Oh, we shouldn't break an exact point at main though, or because that's normally okay.
Yeah, no. Just we
Just
just need it to load the program
Okay,
fast.
makes sense.
So
Uh huh.
yeah. Okay. Then now do info proc mappings. Yeah.
Okay, cool.
All right,
Uh huh.
nice. Yeah. So now we can be
so
able to
that's the
see. Okay,
addresses
so
of
like
libc.
yes, so we can see like the various parts of the program and where they've been loaded at, right?
Uh huh.
So we can see our stack down there. It was loaded at that address.
Sure.
We can be able to see the variables, not variables, the libraries that are loaded, right? So you see libc there. That's the library we use, and you see ld. Ld is the linker.
Oh,
So
uh
pretty
huh.
much because it's dynamically linked, we need this linker to like load to help us get the addresses of the functions in libc.
Okay.
Yeah, that's why we have a GOT table for dynamically linked. Yeah. Anyway, yeah. So now we can be able to get the address of the main function, right?
Yes.
So okay, but the problem
Main
with this is
function.
Wait. I
not
have
main.
uh,
Sorry, not main.
the address
Libc.
of libc. Yeah. So I have one question.
Mm.
In this case, we are talking about finding the address of libc. Um.
Mm.
So this is libc on my system, right? It's not libc, cause yeah, as in
Yeah,
yeah, right?
yeah,
Yeah. So I guess as we do it,
yeah.
we can also do the same in what do the same in pawn tools, because this is how you specify a libc. So I learned somewhere that um,
Uh-huh.
you talked about something being dynamically linked. So uh,
Yeah.
there's a there's a command you run to see what libc is pointed to the
Mm-hmm.
binary. So like when it's running, which libc is it using? So in pawn
Mm-hmm.
tools,
Mm-hmm.
this is just how you, so
Oh,
it
target
gets,
libc.
yeah. So it knows, okay, that's the libc. So you wanna pull what system from that
So
and stuff. Uh huh.
so this gives you the address of where libc is, or
Let me see. I'm not. I think so. Let me see. One sec.
okay, maybe try
Can you
and receive. Yeah, because I've never done it like
can you
this.
can you try and maybe um um the rope gadgets from libc with pawn tools? We see if it has gotten the
Wait, what?
um I was saying,
Yeah.
can we try and maybe okay, that even that's fine. But I wanted to see if you can get
Mm, hmm. So
required
I think
argument is not an integer.
so. I think.
What is above print libc? What's libc itself?
Uh. Oh. Oops.
Well, it's saying it requires an integer.
Let's see. So yeah, yeah. That's
Yeah,
the.
it gets the file
It gets
itself.
the file. Yeah.
Yeah.
So
So
how do you get the base address using this?
get the address, you get the file, whereby now you can more of get the gadgets of the file itself. So it's more of like running
Oh.
RP plus plus on the file to get the gadgets. Are you getting?
Okay. Yeah. Makes total sense. So we have target
Yeah,
rope and we can have libc rope. I think that's as far as I think I'm.
yeah,
Yeah.
yeah,
And
yeah.
then um. Okay. Wait. Because I've never done this. Let's do the rope gadgets and pass in libc so that I see how do you exactly tell, sorry, the libc base address. Rope gadget. Oh god, there's a new VM.
So,
Is there rope?
okay, so you can't.
Yeah?
Uh-huh.
Oh, so okay, you'll be able to get the ropes, but then this will be offset, right? You still can't get the base address until you run it. Or I have a script like let me just so you can use so in whatever in pawn tools when
Uh-huh.
you create a process, right? When you do a process into bracket your
The
I mean
file, yeah. Uh-huh.
process your binary.
Yeah,
Yeah,
yeah.
yeah. You can do there is a function within the process class called libs.
Mm-hmm.
Interesting.
It gives you a mapping of of the of the libraries that are being used. So that just gives you a mapping of the libraries, but I think it's enough for us to do what we want to do. So
Okay, uh-huh.
yeah, so from there, then that's how I was able to get the base address of
Of
libc.
libc. Oh, interesting.
Yeah. Then after that, you just add to the offsets of the gadgets because the gadgets will you get offsets, but you need to figure out the base address.
Yes. Okay, cool. So, all right. Have you shared the script? We have a look, or
Oh, I share this. Okay, let me
Yeah.
do it.
because I still
Pardon
need
the
to learn how to.
shittiness of the script.
No worries.
Yeah, okay. Let me just share. This is A, I think.
One sec.
So I have a function there. This function I used it to get the addresses of the
Share
stock.
Where have you shared it?
shared it on this chart.
Uh,
Maybe I share it on here also.
oh yeah, so, you shared the reverse engineering. Okay.
Yeah.
Huh?
All right. Let's have a look.
Yeah. I've shared it on the chart itself, on the
Oh,
chart
on
of
the
the
charts. Okay.
yeah.
Okay.
Damn.
So
Okay.
I created another function there. Um, okay, I created this function to get the address of the stack.
Okay.
But I also figured out libc, so I used whatever libs. I mean, so maybe just open it and we can go through it, I guess.
Sure thing.
Please, if you have a question, just ask. I'm very disorganized in how to explain the stuff. You just ask. Um, yeah.
Oh, you have a process to get
Um. All right.
Okay.
Okay. So that function pretty much just calls the command proc, uh, the command to cut the proc maps, and then get for me the address range and the stuff that is, I mean, sorry, the address range and the name of the library or of the section of the program that is being loaded.
Okay.
Uh, I'm not sure if I'm making sense. Yeah,
Yeah. Yeah.
but
You
pretty
are.
much I'm just
Mhm.
okay. Okay, cool. And then after that, I just clean it up a bit into a dictionary. That's what I did in the loop there.
Mhm.
I just loop through and I create the dictionary, and then I just return it. So that's what I did. So down there,
Mhm.
in the bases there.
Yeah.
So I kind of used both. I used io.libs and I used the other one, but you can just use one of them, I guess. So I call my function here memory mappings is equals to get mappings from proc. You can print it to see what's up there. But anyway, and then I use that to get the stack base. Yeah.
Interesting.
So this Yeah. So the stack size, I had coded it because I just calculated it offline, but you can just calculate it based on the ranges on that dictionary. And then I found the mprotect address.
Uh-huh.
I just used obj dump minus d into the uh, libc, but I guess you can just use the pawn tools that you were showing the target whatever the way you showed to
Okay.
get the address of mprotect.
yeah.
Um,
Mhm.
and then I I created some gadgets here. So let me see. Yeah, I created some gadgets here. So we know that parameters are usually put in RDI, RDX, then RSI, and if they're more than that, they're put in ECX and EAX, right?
Yeah.
So in this case, I just used RDI, RDX, and RSI. So I looked for these gadgets. I found RDI gadget in the program itself, so that's why it's here. It doesn't have an offset. And then the rest of this two, RDX and RSI, I just found them from libc.
Okay.
And then I have a gadget here to jump to RSP. Okay, I will explain it in a bit, but I'm just going through the code.
All right.
And then I started creating my rope chain. So I put in my junk, which is until the offset.
Yeah.
And then I was like, okay, the next thing I need to do is load my parameters, right?
Mhm.
Into so that I can call on protect.
Yeah.
So I load my parameter using pop. So what popping does is pretty much takes the value that's on top of the stack and puts it in that register, right? So when
Yeah.
I say pop RDI plus my stack base, I'm pretty much providing the address of my stack. And once we run pop RDI, it pushes it into RDI. So now RDI has the address of my stack, right?
Yeah.
But if you look at this gadget, by the way, I don't know why I just wrote it like that. If you look at this gadget, maybe Muginjutsu, just on your other terminal on the left,
Uh-huh.
just do ropa dash dash file main
Do I have Ropa?
search.
I don't have
Don't?
Ropa.
Okay,
One sec, one sec.
can
I usually use Rope Gadget. I don't know if that's how you installed it. No, let me just
yeah, I use ropa, but okay.
give me a sec.
I found a neat tool of using tools to search for rope gadgets. It was
Ah, yeah,
actually interesting.
Mm,
yeah, yeah.
Mm. Yeah, and then you don't have to put like static addresses. But now I'm
Like,
curious, can you find a way of placing and finding the offsets so that you can say libc plus this? Oh, interesting. But I love the clean you just showed me a cleaner way of writing rope chains, Levanto. The way I would have written this rope chain, it will have been in a send. Uh, target.send, then pop
yeah.
RDI, then the value, pop RSI, the value, pop RDX, the value, all that, the rest. Oh, this is clean, and someone can read it properly.
Yeah. Muginjutsu, could I share my screen for like just a second to just explain a bit about rope chains?
yeah, for sure, yeah.
Yeah, just a bit, and then we can go back.
Sure thing.
Flame Astra, you're good, Musioka?
I'm lost, man. But
Okay, where exactly so
uh,
that I can start from there? Sorry, let me just. Um,
the, the parts I got, some parts I didn't. Yeah.
okay, so but beginning with the rope, or let me just a minute. Okay. Um. Okay, let me just do a quick until where we get here. All right. So I hope this is. I guess this is too big, but anyway. All right. So we had this executable here, our main executable. So we did a bunch of static analysis to be able to figure out what did I do? To be able to figure out what's up with this binary, right? So we saw we do a get, we put our input at RBP minus 4, OX40. We found our buffer overflow is at offset 72. So we know that we can overflow our return address, right? Where do we jump to next? But then when we were checking through the binary, we saw that there is nothing that we can use. We can't be able to like jump to a win function because we don't have a win. We don't have something like that. But then when we go through this binary, we're able to see a bunch of stuff, right? We can see that we wait, what? No.
No.
We just have calls to puts, to gets, whatever, and that's it. So we have to figure out what to do.
And also
Right?
you can do and you can't do a shell code because the stack is not executable.
Oh yeah. And when you do checksec, we saw okay, we can't exactly do a shellcode directly because we have an NX bit, right?
Yeah.
So the
So
first
just
thing that yeah.
so if NX was disabled, we could just
Hmm.
pass shellcode and solve the challenge.
And execute a shell, yeah, and use the buffer. You see, if it's using gets, we can use the buffer given to execute shellcode, and we shouldn't have done all this. We're going to do next.
Okay, but in that case, though,
If,
if we didn't have an NX bit
mhm,
enable, if you could execute on the stack,
mhm,
what you could do is so after your junk, right? After
yeah,
the offset, you
yeah,
need to have one gadget to jump to that part of the
pass,
stack, right?
yeah.
Yeah, because we're
Or
trying
you can
to.
put it after the return. You can just put an ops sled and then your shellcode. Because if you have like you can override till the shellcode till the return or more. If if it's using gets, I think you can overwrite everything, then the return you can just put like shell and nope returns, and then the nope, and then after the return you put the what is it called?
But the okay, but okay, if you're trying to overwrite the return, right? That means you're trying to overwrite the address to jump to, right?
Mm,
So you
No,
can't directly overwrite it
no,
with a
you can
payload.
say no, you can
Uh-huh.
say like on the return there's a
Mhm.
challenge is solved where you on the return you put like the return and then plus the return address, if you know the return address, plus like
Mhm.
8 instead of jumping to the buffer area. I just
Mhm.
place the return address plus 8, so it goes next after the return, then it
Oh
address
yeah.
is where it will introduce like no sled and then the shell code.
Ah,
Yeah,
okay.
yeah, you get it.
Yeah, sure. I guess you need to overwrite it with an address to jump to.
Yeah,
Okay.
yeah, but it's basically
Um,
I placed my shell code after the return, not within the buffer address, the address where our buffer is being taken to.
uh,
There, which
ah,
is the same thing. Yeah,
what? Okay,
which
I'm
is
a
the same
bit
thing as
confused.
placing. No, you see, when when you're given um
Mhm.
okay, so the binary uses, let's say example like get to take
Mhm.
input, right? And it stores it somewhere in the buffer. Okay, so
So where
there are
is this
two
buffer? Is it on the stack? Where's the buffer?
still on the stack.
Okay. Uh-huh.
Yeah, so um there are two ways when you are solving it. You can either place your buffer on the stack, your shellcode on the stack, and then return to the beginning of the of the of
Mhm.
the buffer address, or you can place it after the return. After return, you just place your shellcode in there because it will still go in the stack.
Mm.
Yeah,
Mm, okay. All
yeah,
right.
yeah.
Oh, cool. Um, okay, so maybe we continue with this. All right. So in this case, the NX bit is enabled. So we need to find a way to like disable this. So a way to do this is all right, and protect, right? So and protect, as we can see, is a it sets the protection of a region of memory, right? And it takes um, three parameters, which is the address, the pointer to the address, the length of how much memory you want to set the protection to, and the protection itself, right? So in this case, it will be the stack. It will be the stack base, the size of the stack, and the protection, right? So in this case, we know we want to put RWX, which is 7. RWX is 7. Yeah. So now we need to figure out the how to do this, right? So just a minute. Okay. Okay. So what I did, in my case, is I was like, all right, we need to find the base address of our libc, right? So To get this, you can do info proc mappings, or you can do slash proc slash maps, right? To get this. So I just created a function that does that, that cleans up the output of proc slash maps. And then I use that to get my libc base, right? So, and then I was like, okay, now we get where mprotect is. So what I did was I did obj dump minus d, and I check from my libc and I grep and protect, and I could find the offset, that this is the offset here, right? And then I where is it? Yeah, this. So that gives me the actual address when I do libc base plus the offset of the mprotect, right?
Ooh,
And then I was like, okay, yeah.
No, I was like, yeah, continue. That's
Okay,
interesting.
all
Yeah.
right.
Mhm.
Yeah, and then now I need to be able to pass these parameters, right? I
Mhm.
need to pass these parameters. But then we know that, let me just do obj dump minus d main. You can pretty much, no, what did I do? Obj dump, dump minus m, okay. All right, I just want to just do this, okay. So we just take an arbitrary function called this, right? And you can see how the parameters are passed. You have RDI, RSI, EDX, ESX, like that. So I knew that my parameters need to be somehow in this registers before I call my function, right? So I need to find a way to input data into memory, or in this case into a register, right? Now, maybe let me open this. Now we call this data ingestion. Data ingestion slash memory corruption, maybe. Okay. You have you have stuff you want to put into memory and you want to use a rope chain. Okay, how do you do? So the first case, I have data I want to pass as a parameter. I have to put it in an in a register, right? So what you do, you use this a gadget that looks like this. Register return. And then what will have to come next will be your value. What does this mean? This means that, okay, we overwrote our address, right? We overwrote our return address to jump to this place, right? So we jumped here and started executing this. It's like, okay, pop the value that is on the stack to the register here. So so this input of ours, we know that we put it on the stack. Cindy, like we just remember that our input was in a buffer that is on the stack. So when we jump here, it's like, okay, now our IP is here, right? So meaning this is our value that is next on the stack. So we like pop this value into the register that's here, right? And then return. So again, so after this runs, our value will be in our RDI, and when we return, we have another chance to overwrite where we're returning, right? So that's why immediately after this, if we have another parameter, we do again, pop register. Hope that makes sense? It does, right?
Okay, so whenever you're doing a pop on a register, you're pushing it on the stack.
Yeah. So like when you do pop RDI,
Uh-huh.
pop means, let me put it this way. Yeah. So pop means take the value that's on the stack. Pop is pretty much remove from the stack, right? Remove from stack, put into somewhere. So pop RDI means
RDI
remove from the
from the stack.
stack.
Yeah.
Yeah, from the stack, put
Uh-huh.
into RDI. So when you see push, like push RDI, push is like remove from RDI, push it into the stack. So
Okay.
that's,
Uh-huh.
yeah, push and pop, they're like opposites. Yeah.
Interesting. Yeah. Uh-huh.
So yeah, so I was just trying to show you the flow of like how to make sense of a rope function. So we were here, where were we? We were at like, okay, we did our leave, and then we overflowed this, right? Because here is where we had our return.
Yeah.
When we did our buffer overflow, we were here. So we overflowed our return function with this rope chain, right? So
Yes.
what return does, as we remember, it takes the value of the what does it do? It takes the address that is on the stack and puts it at RIP, right? So in this case, when we're returning, we'll be like, okay, we're returning to the value that is just next here because you remember our gadget is actually an address. Do we remember? We found gadgets and we put them as addresses.
Mm.
Make sense?
Yeah.
Yeah, okay. So we were like, okay, return. We returned and jumped to this pop gadget.
Mm-hmm.
Okay, we were at some value somewhere. And it says pop whatever is here, whatever is on the stack, which from our rope was our value, right?
Mm-hmm.
And put it at RDI. So on the stack, tuko hapa. We are here, right? So after we do that, we have done a pop. Sindio, this value will disappear because we popped, and then we are back at a return, right? A return will do the same. Return takes the value that's at an address on the stack and puts it on RIP, right? So it will be the next one, which was our rope, which we passed an address for. Like that. So that's how it moves. Like you pretty much uh you pretty much make use of returns to jump to addresses. Because return has to look back to the stack to take the address that's on the stack and put it on RIP. So that's why when we look for ROP gadgets, whenever you check for like, sorry, let me see. Yeah. So that's why we did roper. Yeah. Search. Did this give me? No, no, no. Let me look for a clean one. Yeah, and we did search pop RDI. You see, it returns to me pop RDI and a red. Of
Return.
course, there are a lot of pops. Yeah,
Yeah.
there are a lot of pop RDIs in my function in my program.
Yeah.
But a gadget is viable only when it has a return afterwards. Because then you can be able to join it with something else and create a longer rope, right? That's why
Oh,
when I
okay. Uh-huh.
even yeah, that's what makes a gadget pretty much. That you can be able to join. Like, let me show you another one. Maybe move Gani RDI, RDX, maybe. Let's see. Yeah. Yeah, you see. So all of this have to have a ret afterwards. That's what makes a gadget. Of course, there's a lot of moves in the program, a lot of them, but it only makes a gadget when it has a ret afterwards. So because it's only with the red that you can join and jump and jump and jump. Yeah,
Yeah. Okay. Makes
yeah,
sense.
yeah, yeah. So in this case, when you're doing a memory corruption, the two main ones that you can use is pop, register, uh, ret, and then immediately afterwards your value, as we have explained, right? Okay.
Yes.
The next one you can do move EDI EDX or move register, right? Of course, it has a ret afterwards. So what this does, this is like you can't call it directly, of course, unless you know what is in EDX, right? But if you don't know what is in EDX, you can always put in the value of EDX by doing this, right? You can say
Yeah.
pop EDX red value, right? So this puts the value into EDX. So now EDX is not empty, EDX is your value. And then and then you also put something in EDI, right?
Yeah.
So this, when you see something with this brackets, it's pretty much like move whatever is in EDX into the address or like into the location that this is pointing to. I'm not sure if it makes sense. This is not the same as if I
So,
do move
uh-huh.
EDI EDX, it's not the same as move
Brackets
EDI
EDI EDX. Okay.
EDX.
So
Yeah,
one is
yeah,
using the actual value of EDI, and the other one is just a pointer to. Is it EDI
yeah.
or yeah?
Yeah, pointer to EDI.
Okay.
No point.
So
No,
No.
the address will be in EDI, right?
yeah,
Uh,
for the second one. So
uh-huh.
Yeah.
in the first one, what this will do, it will pretty much overwrite whatever is in EDI with whatever is in EDX. So it's pretty much move EDX to EDI. That's the
Exactly.
first one.
Yeah.
The second one, yeah, the second one is like move
Overrides the address.
contents, yeah, move whatever is in EDX into the address, no, into the space that the address of EDI points to. Oh my god, I'm making it so complicated. But anyway, this makes sense,
Basically,
right?
basically that means you should make sure EDI contains an address,
Right,
right?
it needs to contain a valid address.
A,
Yeah,
a valid address, yeah, so that you
yeah,
can
yeah,
override the value of that valid address of the address.
yeah,
Yeah, so it should
exactly.
contain a pointer, and you overwrite the value of the pointer.
Yeah, yeah. So this is how to do data ingest, whatever, memory corruption. Um, okay. Another thing in rope is like, okay, we need to jump pretty much. Jump to places. The two places you can jump to, like, I don't know. I'm just loading this from memory. So you might want to jump back to the stack. The gadget that you use here is to jump RSP. When you see this, by the way, when you find a program with this gadget, this is very useful because you pretty much can be able to put your shellcode
In
and just
RSP.
jump into yeah, and just jump into where the shellcode is at. You know, like
Sweet.
if the
Yeah.
shellcode is at the RSP, yeah. So
Yeah.
this is pretty sweet. Yeah, I think that's pretty much it. The rest, if you want to jump somewhere, you just make sure there's a ret before and then your address. So that's pretty much how you jump. Yeah. So a rope chain, the structure of a rep chain is blah blah blah. Wait, is blah blah blah. Ret, uh, address, blah blah blah. Ret, whatever. Address to gadgets. Yeah. So ret is pretty much the thing that the glue that like grows the rope
The
chain.
rope chain. Yeah. Sweet.
Yeah.
Yeah.
Yeah. So that makes sense now, guys. A flame, Astra questions.
Uh, yeah, that makes sense. I think gotten something out of it. Don't know.
All right. So now when you go back to this file, now I think the rope can make sense, right? We're like, okay, we have our junk file, our junk input up to the offset. We get to the point where we want to overwrite our return, right? We overwrite it with the address to our rope gadget, pop RDI, and we give it the value of what we want to put into RDI, which is the address of our stack, right? And then, of course, there was a ret here. So we return back to another gadget that pops our RSI. So RSI, we want to put the size of our stack, right? We return again. We go to a gadget that pops RDX. Put 7 because that's the permission RWX. And then now, after that, because there's a ret here, we return back to the function that we want to jump to call. Yeah, which is mprotect. So after this, pretty much we're like, okay, ready. We've set the stack permissions to be read, write, executable. And then now we jump back to the RSP. We jump back to the stack
And
and
pass
then we
in the
put our
payload.
payload.
Nice. Yeah.
Yeah,
Makes sense.
and that's it. Yeah. So
I
the
just
thing that gave me some
Levanto.
headache here. Yeah.
I just have a question. So whenever you're calling those functions, do they have to exist in the binary? It's like they can even exist in libc?
Yeah, so in this case, we're getting them from libc.
Oh,
Yeah, but
But they
yeah,
can
but you
also
have
exist in
to.
the binary.
Yeah,
yeah.
they can
Mostly
exist.
nimeona exist for binary. Then the second question is, given the fact that sometimes unakuanga SLR enabled, can those addresses be hard coded?
You have to leak them. You have to find a way to leak the addresses. The offsets, of course, this offsets, of course, will not change.
Okay.
Even in SAL, the offsets do not change. What changes the
Mhm.
base?
Okay.
So you'll have to find a way to leak them depending on how the challenge is like.
Okay.
Yeah.
Because basically, ROP is ideally used to defeat SLR and uh, stack
Oh
execution.
yeah.
Yeah.
So
So
the thing
Levanto,
that
just a quick one. So what you're saying is that even if some binaries inakuanga na NX enabled, still there is a way you can write to memory and execute.
yeah
Like this example.
Now this is a
yeah.
new one, but anyway, thanks. Yeah, I've learned something new.
Okay, yeah. This way I had to like call and protect, right? Um,
Yeah.
in another way, I did it in two different ways. In another way, I wrote to a writable part in memory. I will share this script here. I wrote the input to another part of memory, and then I called system. In this case, I called system.
So kind of like
Similar to
in retired.
yeah, exactly. It's
Awesome.
kind of like in retired. Yeah.
Sweet.
Let me send this. .py. Yeah. Okay. I guess now I return the mantle to our guy.
One question before you. Uh, so how do you get the offsets?
The offsets. So I do an obj dump minus d to disassemble, and I just grab, and I find the function name call the call to the first function name. But then John Collins and Numi showed us how to use
Controls.
to pawn tools to get the function addresses. Maybe Mugenjutsu can show us that way, but I just wanted to explain the rope part. Yeah, actually, yeah, I can also share another link to the live CTFs from this DevCon that happened. So they mostly do pawn and reversing, and you can see how these guys like create their rope chains. You can get some ideas on like how to make use of certain gadgets or how to yeah. I'll share that.
Okay,
Okay.
awesome.
Hmm. Okay. There's also like you can run LDD on the binary, and then it shows where um the libc that it's using to run. So I guess this would be the base address.
No.
It's all okay. Cool.
Yeah, because you have to like find it once it has been loaded.
All right. All
I
right.
guess. Yeah. Yeah, but we can prove that theory. Like you can load it and then we can see if they're the same. Probably won't be.
Okay. Is it this?
It should be the first
The
occurrence of it.
the first
Yeah,
occurrence.
that
Okay.
one.
So it's this one.
Yeah. Is it the same?
Let me see. No.
Nope.
Yep, they're not the same.
Yeah.
Okay. All right.
Okay.
So we have that, right?
Yeah.
Um,
But that. Ooh. Okay. That will change. Actually.
oh yeah, so yeah, you have to do it every time it runs.
Yeah. So like, I think we can just use the scripts that I put there.
Sure thing. Let me grab it from the get mappings. But I saw you do
Yeah.
something interesting here.
The io.libs.
Yes.
Yeah, you can also do that one. I thought that one would give me also the address of like the stack, but it didn't. It said something on the documentation about. Let's continue. Let me find it. Um,
So, um,
Let me come.
sure.
what was it?
Where is it? You need to get the absolute. Is it the same as yours? Yours does not have the. Wait. Oh yeah, it's the same. It's the same.
Mm-hmm.
Hmm. Oh yeah. So libs, it
Mm-hmm.
returns a directory mapping of the path of each shared library loaded by the process to the address it is loaded. So yeah, it actually does what it's meant to do, but it doesn't give you the address of the stack, for example. So that's why I had to create the other custom script, the other function. Yeah.
Okay.
Yeah.
So we still need the get mappings.
Yeah.
Okay.
I wish there was, maybe there's a better way actually.
I'll
Or
try to
to
find a
think
better
about
way.
it
Yeah.
offline.
Uh-huh.
Yeah. Sweet. Okay.
Okay. How do I place this? All right. Let's see. So
Yeah.
coming back to your code,
So we need to get and
the
protect.
wait, we first don't we start with this, or you've jumped all the way
Oh
here?
yeah, sure.
Yeah. So
Oh, okay.
this how you get the process ID.
Yeah.
Okay, interesting. So where is
Again,
this?
my code might be shitty, so give me.
Is mm-hmm. Oops. And then we were finding the memory mappings from the
Yeah, from the function.
um
Get, yeah.
proc ID though. Yeah.
Mm.
And then is where we
We get the, so we get the libc. Actually, you can just copy that, right?
we need
Yes.
the we need this.
Yeah, I don't think we need it actually, since we can get it from. Yeah, we need it. We need it. Need it.
So okay, so this is your way of
There's a.
finding. So this is your way of finding the libc base.
Yeah.
Okay,
There is a
that's cool.
bug in my function, actually. Know what the bug is?
What?
The bug is that I'm using a dictionary to parse the the output from that I got from the maps file, right? The proc maps, right? But you remember in the proc maps, like for example in libc, like things occur, the entries for libc are more than one. But then I use the name as the key. Because the key is unique, that it gets overwritten all the time. So
Uh-huh.
the the value of libc using that function
Uh-huh.
is the last one. It's not the correct one.
Okay.
You get what I mean?
Yeah, yeah.
Yeah, yeah.
So,
So
uh-huh.
that's a bug, but it won't affect this one.
Okay, okay, okay. So, get the libc base here. Okay, let's copy this. Where did you get the stack size though? Levanto. Am I the one who's lost, guys? Oh no! No! No way. Yeah, okay, that's fine.